Hello everybody, so let's continue talking about speciation. We covered allopatric speciation in another video, and the focus of this particular video is sympatric speciation. So sympatric speciation happens when individuals in a population are not physically isolated from one another, but they become reproductively and genetically isolated from one another. Once they become genetically and reproductively isolated from one another, then other evolutionary forces act on them and they become new species. This is called sympatric speciation. And it was once thought that this was not very common in nature, but we found that it actually is quite common in nature. So how does this happen? So let's look at this figure here. So say we have a population of organisms, okay, that in which there are individuals that coexist with one another and they breed with one another. However, a mutation arises in one or more individuals in that population, and those mutant individuals stop interbreeding with the normal individuals. That is, they've become reproductively and genetically isolated from one another. So only mutant individuals breed with one another and only normal individuals breed with one another. Then evolutionary forces act on those mutant and normal individuals and cause speciation to occur. This is how sympatric speciation happens. So these mutant and normal individuals are geographically close to one another. They could interbreed if they chose, but they don't for one reason or another. So let's talk about an example of how sympatric speciation can actually result in the production of new species. So let's take the example of the soapberry beetles, and in your textbook they actually talk about fruit flies as an example of sympatric speciation, so you should review that example. But in this particular example I want to talk about soapberry beetles and soapberry trees. So soapberry beetles are these little guys here, and what they do is they feed on the fruits, and more specifically the seeds of the soapberry tree. And soapberry trees are really cool. Their fruits can be quite large. You can see up here in the corner an example of a exotic soapberry species. And literally they're called soapberry because you can take these fruits, you can cut them in half and rub them between your hands with a little bit of water and they produce soap. That's why they're called soapberry trees. Well, in the soapberry beetle feeds on soapberry trees, and soapberry beetle is native to the southeastern United States, including Florida. This is one of the reasons why I like to include this example, is because I'm in Florida and I know a lot about soapberries. Well, normal soapberry beetles feed on fruits that are quite large in size. Okay, and the fruits on which they are feeding are fruits from a native species of soapberry tree. Okay, and so you have these soapberry beetles who have been feeding, that are native to the southeastern U.S., that have been feeding on this native species of soapberry for a long period of time. Within this population of soapberry beetles, though, there are beetles that have longer beaks that they use to penetrate fruits, and then some of them have shorter beaks, okay, which can also penetrate the fruits and allow them to eat the seeds. So there's variability in this population already, okay. What happened was that in the, I guess it was like the 1960s, a non-native species of soapberry tree was introduced into Florida and actually throughout the southeastern United States. And these soapberry trees had fruits that were smaller, okay? And so soapberry beetles within this variable native population of soapberry beetles already existing in Florida, those with shorter beaks actually can feed more effectively on the smaller fruits of this non-native introduced soapberry tree. So what happens with soapberry beetles and how it is sympatric speciation has happened in this population of soapberry beetles is that the soapberry beetles, what they do is they feed on the fruits of the soapberry tree, both on the native and invasive species of soapberry trees. They feed on the seeds of the soapberry tree, and then they lay their eggs there, and individuals usually hatch, pupate, and grow up on the same tree, okay? So what you have is you started having shorter-beaked soapberry beetles feeding mostly on the invasive species, and longer-beaked soapberry beetles feeding on the larger fruits of the native species, okay? They are perfectly capable of flying once they're adults from tree to tree and utilizing a variety of different food resources, but they're not really doing that because, in particular with the shorter-beaked soapberry species, they can't really anymore use or eat the fruits, the seeds in the fruits of the native soapberry tree. So what you see is that these populations have become genetically separated from one another. They're reproductively isolated from one another, such that the short-beaked soapberry beetles only feed on the native, on the invasive species and non-native species of soapberry tree. And then there are the native soapberry trees on which the soapberry beetles feed, and they have to have a longer proboscis. And they've just literally stopped breeding with one another. They've become reproductively isolated from one another because of the introduction of this invasive species. And what this is causing is disruptive speciation. Remember, if you go back to, disruptive selection. If you go back to the lecture on natural selection, you'll see what I'm talking about. So it is causing disruptive selection in this population of organisms that are geographically able to interbreed with one another, but don't. Okay, because of the differences in the beak length of the different beetles. So this has led to speciation within two groups of organisms in Florida. And there are also other examples as well. Now there's another